This month, we're talking about electrical safety. And it's important that we talk about electrical safety because although it's not generally a hazard that we create, it is one that our employees are often exposed to. So we need to make sure that we've done what we need to alert them to that hazard because electricity continues to be one of the top fatal incidents with OSHA. There we go. I'll start off, as always, to remind you that the FCA safety line is here for you to ask questions. If you go ahead and have a question, give us a call. We'll give you some advice. The questions are private and they're answered by a safety professional, generally yours truly. All right, so when we talk about electrical safety, there's three things that we're really focusing in on, three hazards that we really have to do. The first is electrical shock. And this is shock that is not enough to kill somebody, but is definitely enough to knock somebody off a ladder. So the issue with lower electrical, knocking somebody off of a ladder is a pretty common issue that can lead to a fatality with electrical. Second is arc flash. An arc flash is a lot less common, but a lot more severe. We'll talk about arc flash. I'll show you a little demonstration of it that can show you how incredibly violent an arc flash is and what situations you may see on the work site that are likely to cause an arc flash. And then the last is electrocution. On most of my electrical safety presentations, I put in a trick question asking everybody, hey, raise your hand if you're electrocuted. But the reason it's a trick question is because electrocution is death caused by electric shock. Right? So this is always something we need to make sure that we're aware of. And it doesn't have to be a large shock to cause death. It can affect the breathing center of the brain, which stops the diaphragm from moving. It can do an electrical stimulation to the diaphragm, which causes it to constrict and not be able to relax, which leads to asphyxiation. And of course, if we get the right path of that electrical current, it can go through the heart and cause cardiac arrest. But what level of electricity are we worried about? Everybody I talk to is more worried about high voltage, above 240, right? 480, 720. That's where the real hazard is. And that's just not true. Almost 80% of the fatalities early on in the teens were from household voltage. That's where we have the most exposure, and it definitely has enough voltage, enough amperage to kill somebody. So I was recently talking to one of my peers here at AmeriSafe Group, and he came up with a better metaphor than I had before. And it comes down to the pressure. Right? It's not the voltage that kills you, it's the amperage that kills you. And a good way to look at this is looking at it through water and a hose. Right? If we have a fire hose, everybody knows that that can cause some problems. There's a lot of water moving through that. But a garden hose doesn't have much water. That is your voltage, right? And a garden hose is your household voltage, 120, 240, and then or 220, and then you go to your fire hose, and that's your high voltage, your 240, your 480, and all of that. But when we start looking about amperage, amperage is the pressure of the water coming out of that hose. So even when you have a smaller wattage or voltage, like household and a garden hose, if you hook that up to a pressure washer, even though you may get the same amount of water through it, when that pressure is jacked up to 150 psi, is it now just getting wet? No. At that point in time, we can have water pressure that can cut the skin, right? And that is where we really want to know that it's not the voltage that truly makes it dangerous, but the amperage. The amperage of electricity is what will kill you. And it takes less than 1 amperage to kill you. So we'll talk about that a little bit later. I'll show you a diagram that has that kind of stuff. When we look at what types of professions have run into the problem of electrocution, we find that construction is the largest percentage. But then again, we still see in that red square, making it so that we're a little over 2/3 if you consider installation, maintenance, and repair, which some of our work does fall into. So electrocution is a hazard that our membership deal with every day, our employees deal with every day. So next, I'm going to show you a short video. This comes from WorkSafe BC, which is a Canadian province. They have a lot of very good videos that you can utilize for training your people. I included this one, specifically the first of 7, because it has to do with arc flash and a small painting contract. So let me adjust my settings here for a second. All right, and here we go. Can everybody hear this?
Talk about watching your butt. There were these guys I knew. Grew up together. Real good times. They seemed to have a good time doing just about anything. I especially remember John as having a really good sense of humor. Always joking around. Anyway, they got a loan, bought this truck, and went into the painting business. And they were doing pretty good. They got a contract to paint this new building with this sealant stuff, right? Highly flammable. Anyway, they were up on these ladders. No one remembered to check about the power lines. I guess it never occurred to anybody. So John swung his pole up by this power line, right? Well, it's hard to say, but it didn't even look like he touched it. Well, the sucker arced right across to John's wooden pole, electrocuted John, and then I'd seen the whole freaking shooting match explode. Poof! Well, there's this great big ball of flame. Bill was thrown clear or jumped clear, I don't know. But still he got burned pretty bad because the paint was like burning napalm, eh? The cops said it was hard to tell whether the shock or the fire killed John, because all that was left of him was a pile of charcoal, because the heat from the fire was so intense. People say they saw him moving around in the flames, but the coroner said it was just the body expanding and contracting in the heat. I always watch myself around power lines.
All right, let me adjust my settings again. So really, this is a good educational tool to kind of get the attention of your employees. You can use this during a training. I left the name of it. You can search that on YouTube and it'll come right up. If you want to have that recorded, I will be PDFing this presentation at the end and providing it so that the links I have in the bottom, you'll be able to see where you can get those. But the point I always notice on this is that they did not come in contact with the power lines. And that's a common misconception. You do not need to touch a uninsulated line in order for it to arc if you just get close to it. The second misconception is that they were using wooden or possibly fiberglass rolling poles. So those don't really conduct electricity, do they? Yes, they do. Pretty much everything conducts electricity unless you have an extremely clean, non-conductive material. So a brand new wooden rolling pole is not likely to conduct a lot of electricity. Would it conduct enough to cause a spark that could ignite a flammable environment? Definitely. So what you have here is a picture of overhead power lines. And what I wanted to do is kind of discuss what we see on our standard jobs, right? With our regular distribution power lines, these are not the steel towers that are really highly elevated. These are what you normally see on the side of a residential road, right? And on top, we have our primary conductor and our neutral conductor. And we have a transformer. This steps that power down to a level that you can bring it into a house or a facility. That goes to the secondary main. And then you generally see a service drop going to the facility, right? Or the house. Now, this service drop is what we come into contact with most. The secondary line may be right along where we're working, as may the primary conductor, right? But the higher up it is, the harder it is for us to touch. Our next question is, are these lines insulated? Only by distance. Okay, your secondary main is not going to be insulated. Your primary and neutral conductors up top are not going to be insulated. They weigh too much to insulate and hang in the air. So the way that we insulate power lines is by distance. The problem is that as painters, as finishers, we often bring mobile elevated work platforms, roller poles, extension ladders, and other things that can get us closer to those power lines than we would be on the ground. So we need to take that into consideration. The service drop is sometimes insulated, but you cannot tell just by looking at it. Sometimes the service drop that goes between the building and the pole only has weatherproofing on it to extend the life of that line. So what do your employees need to know? That power lines are not insulated, right? That they do not need to come into contact. Most service drops are insulated, but not all, but they're still hazardous. You don't have to come in contact with those lines for electricity to arc out. Now, when you start dealing with those higher voltage transmission lines, those that are in hundreds of thousands of volts, they can jump out, about 15 feet at the highest level of transmission. Now, you're not getting close to those lines in anything that you're painting. But the smaller lines can still jump out without being touched. The lower level of transmission can jump about 2 to 3 feet. So we do not want to get close to them. And we also have to get rid of the fallacy that I'm safe because this does not conduct electricity. I've never seen any finishing contractor with tools that don't have some kind of dirt, paint, finish, splatter on them. And once you get some other material onto a non-conductive material, it becomes conductive. So when we're using aluminum ladders or when we're using fiberglass ladders, we need to make sure we take into consideration where the power lines are leading up to the job. So in this picture, you see these lower lines, and these are generally communication lines, but the lines that are coming off these little transformer cans going into the facility, those are your secondary lines, and those are going to be energized. So how close can you get? You can get on most of what you're dealing with 10 feet. Right, so 50 kV is 50,000 volts, right? So we start dealing with all transmission level is going to be at, or all distribution level, everything on those wooden poles for the most part, are going to be 10 feet away. But as that voltage gets higher into transmission, those distances get farther. So how do you know the voltage? On the side of every pole, you have an indicator, right? A series of numbers. And that's what the utility company puts on it, so they know which pole it is. you can call them with that identification number, call the utility, and they will tell you what the voltage is. You can also ask for what the voltage is of the service drop to the building. Leaving this pole going to this address, what is the voltage of that service drop? And that becomes important because we generally need to paint near a service drop, right? We may need to put up scaffold near a service drop. And before we can do that, we need to know what the voltage is and whether or not the line is insulated. This is information you can get from the utility. The time to do this is during your pre-bid, right? Or at the very least, before you go out to that site, right? Before you mobilize to that site, we need to know what those power lines are, what their voltage is, what the drop voltage is, servicing that piece of equipment or that facility. Now, a lot of times we get lucky and this is underground. When it's underground, not a problem for us, right? We're not generally digging, so no issue. But that overhead, we need to know because we need to know how close we can get, and not just with our static equipment, but any tools, ladders, extension poles, your aerial lifts. All of those need to maintain this minimum of 10 feet distance. That doesn't mean you can get the lift to 10 feet away and then reach as far as you need to get the painting done. Nothing is allowed to go closer than that 10 feet. Now, when we have those service drops, we can't set it up like this, right? But if that drop is less than 300 volts, which is what you're going to get in most residential situations, right? And light manufacturing sometimes is and sometimes isn't less than 300 volts, right? We can find out this information from the utility company to tell us what is the voltage in that service drop to this address. That way you know if it's less than 300 feet and it is insulated, then that distance closes to 3 feet for scaffolding, right? We're allowed to set up scaffolding 3 feet away from insulated lines below 300 volts. But once again, this is part of your pre-bid process. You need to know what the electrical hazards are on the sites so that you can make sure you have the right budget to be able to execute and still make your profits. Because if we give that short budget, what are our employees going to do? A lot of times, if we're not giving direct instruction, they'll get closer than they need to, closer than they should to get the job done. So I said before we talk about what that voltage is that can really hurt someone. And it's not much. When we look at amperage, which is what actually kills people, not voltage, but amperage, it takes, 3/100 of a volt to cause that possible suffocation, right? And it has to do with the path of travel. And I'm sure we've all at some point in our life gotten some small shock from an electrical system. The difference between life and death with small shocks are the path that's traveled. If the shock goes in one hand and then goes out to the other, right, from one hand to another as its path of travel, it's going to cross directly through the heart, at which point 1/10 of an amp will kill somebody, right, is likely to kill somebody. If we have 1/3 of an amp, regardless of where your path is, it's really going to stop breathing, right? And then you get up to 1 amp and you can light a 1-watt light bulb. You go up to 15 amps, and that is when the smallest circuit breaker you have is going to trip. Because circuit breakers are designed to protect the electrical system and stop your house from burning down. They're not meant to protect people, except for the people in the house not wanting to get burnt down, right? But they do not protect from shock. What protects from shock is a ground fault circuit interrupter. Ground fault circuit interrupters are designed to trip in 1/5 of a second at 0.005 amps, right? So 5/1000ths of an amp goes and it notices and it will trip it. That way, when we have a fault that small, and what a fault means is that the electricity that's going into the system is not flowing back where it's supposed to. When it notices that, it trips out, and that's less than a second, and it is designed to protect people. They need to be used when we are performing construction activities. So pretty much any activity that you're performing requires a GFCI. We also need them in wet and damp locations. Now, there's a problem with GFCIs. GFCIs will trip on some equipment. I know when using an airless pump that has a heavy draw, it's going to trip that GFCI all day long. So we may need to go without the GFCI on an airless pump. But all power tools need to be in a GFCI. So if we're using a drill to mix up our material, if we're using angle grinder or a sander, these need to be plugged into GFCI outlets. This is a pigtail, which is a ground fault circuit interrupter you can plug in after it goes into a regular outlet. If you already have a GFCI outlet, such as temporary power, right? You go to a job site and the GC is already set up temporary power, that is on a GFCI outlet. That's one of the requirements for temporary power, that it be on a GFCI outlet. So plugging in a GFCI pigtail like this into a GFCI outlet, I've had different opinions from different electricians, about 50-50. 50% of them say it's not going to impact it, it'll work fine. And the other half tell me that a GFCI plugged into a GFCI outlet can cause a problem. So I suggest that you go with one GFCI. If you already have a GFCI outlet, do not use a pigtail. If you don't have a GFCI outlet, then do use a GFCI pigtail. As long as we're talking electrical safety, I'll bring up lockout tagout. Lockout tagout is not a huge part of what you do outside of perhaps in your own facility. But when we have a piece of equipment, if we're going to be working on it, the picture down in the bottom is a chop saw if we're changing that blade out, right? If we're working on an airless pump and we need to remove that filter, right? Something like that. We want to make sure that we unplug that equipment before we open it up. And then we keep that plug under the control of the employee service. What I mean by that is don't pull it out of the outlet and leave it right there on the floor next to the outlet, where a helpful safety guy can walk by and plug that in because it's usually plugged in, right? You want to make sure you have it at your feet when working on a piece of equipment that is corded. So next we'll talk about arc flash. What happens with arc flash is, and there's a diagram that explains it a lot better a little bit later, but we have a fault across phases. And this causes an explosion of plasma and fire and force, shrapnel, light, sound. It says it's hotter than the sun by a magnitude of almost 6. Or, it's a magnitude of almost 4. It's a huge release of heat. So where are we exposed to that? I'm going to show you a couple pictures here, and I'm pretty sure you've seen this on your job sites from time to time. Right? We have a circuit breaker panel here that we don't know whether it's energized or not, and it has no cover. We should not be working around any of these unless we can have an electrician verify that it's de-energized. Same with this, putting the cardboard on here, or my favorite, cardboard with hot written across it, as if that will protect it. That's where we really run into, and that's likely your largest exposure to arc flash. We need to make sure that we train our employees to know that when we come into an opening like this, go to the general contractor and say, I cannot work in this area until until I have an electrician verify that this is de-energized. If they know it's de-energized, the electrician can come over and show me with a tester. They have voltage testers on them to do exactly that. Verify that these are de-energized before you work around, because it could be their lives that are at risk. Really, whenever we interact with any piece of equipment that has what they call exposed bus, which is on the back side of this panel, right? Whenever you have a bunch of wires going into a panel like this, there is exposed bus. And there's lots of different things that can cause that fault, right? But mostly what it comes down to is drop tools, or say if you were spraying and it was a flammable material. Fire is plasma, which conducts electricity. So if it gets into here, it can cause an arc, which will cause a spark, which will then travel across phases and create an arc flash. Right. So we need to make sure that we're aware of that and that we train our employees. I do not know over the 15 years I spent in the field how many times I painted around energized electrical panels like this, but it was common to see a cardboard with hot written across it and me painting right up around it like you'd see in this picture of cinder block on the bottom right. Okay? And that just is not an acceptable risk to put our employees through. So this is a reenactment of an arc flash in slow motion. Very slow motion. This is an incredibly violent reaction. And the arc flash gear that we give electrical workers to work in energized situations are not designed to protect employees from harm. They're designed to make the interaction survivable. Okay, the FR clothes that are provided to electricians will catch on fire at 3,600 degrees. Everything catches on fire at 3,600 or 36,000 degrees. They're designed to go out immediately within a certain number of milliseconds so that the secondary burns don't set in. And so you can see that kind of violence that we're talking about with that arc flash. And here is the mechanics of it. Right, we start by having a fault across two phases, two electrical circuits. Right, and it lets out intense UV light that can damage the eyes. Solid copper that is in that area turns into vapor, right, and then expands explosively, along with hot air expanding. Molten metal from that fixture is going to be flying, as well as sound waves that are usually loud enough to deafen, break eardrums, and pressure waves that can throw you many feet. And then shrapnel comes out as well, right? So obviously we don't want to be anywhere near an arc flash. And the best way to do that is not allowing our people to work near exposed electrical. The best way to get that to work is empower our employees to bring it up to the general contractor when they see it and refuse to work around it. Yep, I went a little bit fast on that. So you train your employees to the hazard, right? Empower your foreman to refuse to work near unsecured panels. Document your communication with general contractors. If they are giving any pushback, we need to make sure that they have those panels appropriately guarded, which means having dead fronts on. The dead front is what you see when you open up your circuit breaker panel and you don't see any wires, right? If you're not seeing any wires, and the dead front is on. Train our employees about arc flash boundaries. If they're going to be working near energized electrical that electricians are working on, then we may want to train them on those arc flash boundaries. And there's a video here on YouTube that you can go to that will explain them pretty quickly. I didn't include the video in this training. It's about 4 minutes long, but it talks about the different boundaries that are required to work on that electrical, knowing that your employees have to stay outside of the arc flash boundary. And an arc flash boundary needs to be listed on the sticker on that electrical equipment. That's a requirement of NFPA 70E. For all electrical equipment, they need to have an arc flash sticker that says what the boundaries are. And the largest boundary is the arc flash boundary, and your employees have no business inside that arc flash boundary when the cover is taken off that electrical. So I have some resources for you for training your employees on what these issues are. These are all YouTube, whether it's from WorkSafe BC, OSHA, and then there's a YouTube, I believe it's from a utility company, showing a ladder arcing off of power lines. And then the arc flash slow motion, which I showed, and the electrical boundary video that I talked about. All of these are good resources for you to utilize to train your people on what some of these hazards are, at the very least to get their attention during this discussion. All right, do I have any questions on electrical safety, power lines, arc flash, any of that?
Hey, Mike. Hey, hi, it's Peter Graham. How are you today?
Hey, Peter, doing good.
Great, great. I got a quick question. I did miss the first 7 or 8 minutes. I apologize for that. I was stuck on a call.
Not a problem.
I just have a question, like kind of for the group too. You know, everyone on this call probably knows you're painting in a tenant space like downtown or finishing, drywall finishing, and you've got little electrical outlets without covers on them that have wires inside of them with wire caps on them.
Yep.
The wires might be tucked inside that little metal outlet, you know, what do others do? You know, I mean, are we allowed to just paint up around those?
Okay.
You know, without a cover on it, because you can't paint with the cover on it because you can't paint close enough. The electrician's not there to put all the covers on.
Yep. And here's what I have a couple answers for you, Peter.
Sure.
First of all, I want to tell you that those individual circuits that you have for electrical outlets and junction boxes,
Yes.
those are not a hazard of arc flash. Okay?
Right.
That's an individual circuit, and you can't have an arc flash off of an individual circuit. Now, that doesn't mean you can't get a spark off of it.
That's what I mean. Just an electrical shock of some sort.
You can get a spark off of it, right? You can get an electrical contact off of it.
Yep.
Now OSHA requires that anywhere where a junction's made, where you have your, where you have one of those caps that twist on to connect two pieces of wire. Those all need to be in covered junction boxes with the covers on them. Joseph, I got your message. I'll get to that question in just a second. So they're required to put covers on those. We don't always see them. They are a hazard, but they're not a hazard if you do not touch them. Ideally, we should be asking, if we do not have covers on it, can you please de-energize those circuits? There's no reason for them to be on if you don't have covers on. Right, and a lot of times the general contractor will keep all of that de-energized until they come to a time when it's time to energize, which is generally once finished. That's a conversation you can have with the general contractor. Ask them to keep it. The hazard, I do not think is exceptionally high as long as we're not touching that, right?
Yeah,
As long as we're not spraying a flammable material that is looking for an ignition source, because those can definitely be an ignition source. But if we're spraying latex or brush and rolling latex, the hazard isn't exceptionally high, but if you were to be exposing your employee to that hazard and OSHA saw you, could they cite you? Definitely.
yeah, that's what I was more wondering.
Yes, they can cite you for it. So as far as compliance goes, you should be requiring the general contractor, if they're not going to have covers on it, to keep that de-energized. But that's also a double-edged sword. Where are you getting your power from?
Yeah, right.
So
Yeah.
oftentimes OSHA regulation is not designed with ease of getting the job done in mind. That is definitely could be considered an exposure, and I could see a multi-citation or a multi-employer citation come in and tag you as an exposing employer.
Yeah. Yeah, it's a tough one because you almost need like even wall switches or whatever electrical outlets. You need the cover off to paint to cut around it nicely. And yeah. So anyways, it is just a tough one for compliance, but we just train our employees, like you said, don't touch it. And if wires are actually protruding out of the wall, they're coming out, stop, grab the electrician, grab the general. At least get them tucked into where the exposure's a little into the wall or into the outlet box.
And to be clear on this, Peter, I think if what you had was a light switch that is attached and wired without a plate on it, I do not believe you would be cited for that. If you had a junction box with a junction made using those screw-on caps to connect two wires, I do think you would be cited.
Yeah. Got it. Thank you.
You're welcome.
Hey, Mike, what about those socket blockers or whatever, those clear plastic things you can buy that just looks like you just pop right on the outlet or the switches? You know what I'm talking about? We've looked at those before.
I don't think, John, I think you're talking about a different hazard here, because I think what Peter's talking about is when they remove that plastic frame on the outside of a light switch so you can paint around it. Otherwise, it sticks that plate to the wall, and when you pull it off, it destroys it.
Yes.
If we have an outlet in the wall, we don't have to worry about covering up the plug outlet itself. It's just that opening around it that you could get to the wires.
Okay.
All right, Joseph, can you briefly give us about electrical line shutoffs, service line shutoffs, flagging, ideas, costs, and timelines? Yep, not a problem. So if you know that you're going to have power lines or even secondary drops that are going to be close, then you can talk to the utility company with notice. If you can get agreement of the building owner, you may be able to get the power to that facility shut off with notice. And it generally does not cost anything to have the utility cut the power there. It's a really easy process. There's pretty much a circuit breaker switch up by that transformer, and the electrician, utility worker comes out with a long pole, pulls it, do their work, and they can put it back in later that day. That does work, although it's generally very challenging to get agreement from a facility owner to lose power to their facility. So your other options come with, on smaller jobs, it's pretty easy to get them to come out and put those insulating blankets, either blankets or those orange covers that stop contact with that line. And those are going to help eliminate that hazard. That does not allow you to get that much closer to it. When we're talking about cranes, when we're talking about moops, it stops us from, or moops, ladders, extension poles, it stops us from accidentally coming in contact with it, and will stop an arc from jumping out to it as long as it's fully covered. The utility companies will generally do this with a month's notice, free of charge. Now, when we have large projects with a power line that is going to be a problem, with enough notice, we can get the utility company to come out and put extra arms on the power lines and then move the power lines farther away. They can usually move it from 3 to 5 feet to one side or the other of that pole. So that generally does cost. I do not know what the cost is, but it's generally not an exorbitant one, right? The utility absorbs some of that cost. They don't charge you all of the cost of doing it, but they do cause some cost. The second is shutting down a line entirely. Getting a power line shut down entirely takes a good year to year and a half to get the planning put in place. This is more of a general contractor issue than a subcontractor issue. Right? If they have not planned well ahead by the time that bid comes to you, it's going to be too late to get the power line itself shut off. The service line does not take a lot of notice, but getting the power line itself shut down, the power company has to plan for that and make sure that everything is backfed from another substation so that nobody loses power when they take that out. There's a socket blocket cover, and maybe this is what John was talking about, that you can put up there for painting around it, and then you definitely are covered. So thanks for pointing that one out. That is a good solution to get rid of that gray area, right?
You can get them for switches and stuff too, it looks like.
All right, great. I was not aware of those, so that's fantastic. So now let's move on to our record keeping reminders. It's February, so everybody should already have their summary posted, right? So every February 1st through April 30th, we need to post a 300A form showing where our employees can see them, right? So that can be challenging when all the employees are on different job sites, but we do need to post that where employees can see it. So if we have a central location that employees meet, we can place it there. The thing that is newer, it's not new, but it's newer, is electronic submittal. So OSHA now requires that we use their injury tracking application to enter the information from our 300A. So if you have at least 20 employers or 20 employees, you need to do a injury tracking application electronic submittal. Now, when I do my OSHA top 10, the last few years, record keeping has been in there, and the most commonly written citation is not performing the electronic submittal. Right, so that electronic submittal is due by March 2nd, so you have a couple days to put it in, or a few days here to put it in. The way you get there is go to the injury tracking application at OSHA.gov. The homepage, then you can find that injury tracking application. If it doesn't become readily apparent, type injury tracking application into that search bar on the OSHA site, and it'll take you right there. They have an FAQ, which tells you pretty much all you need to know. You need to go ahead and sign in and get yourself a login for your company. There should only be one login for each organization, right? And that login can be altered if the person who had that login no longer works for you, so you don't have access to that. The FAQ covers that situation and tells you how to correct it so that you're not creating multiple establishments when you only want one. Okay, so go ahead, fill that out. It's pretty straightforward and easy. The 300A form, all that information goes in and OSHA publishes that. And they do use that for choosing where they're going to be looking. Right, so unfortunately, they do that for picking who to inspect, but it is still a requirement. And if you get an inspection and you have not been electronically submitting this, they will definitely be writing you a citation for it. OSHA estimates about 20 minutes to complete. So create a login, one single login for the company, unless you already have one, in which case just go and submit. So I'll finish up like I do each month. If you have any safety questions, please reach out to the FCA safety line. We are happy to answer your questions. I'll get back to you as quickly as I can. And if I don't know the answer, somebody on my team will, and we'll make sure we get you in contact.